Veggies Corner, we're going to look at graphing inequalities and two variables, and this is day 2. We're going to start off with a word problem. It says Matt has a $50 gift card for a website that sells apps and games. Games cost $2.50 each, and apps cost $1.25. Write and graph an inequality that represents the possible combinations of apps and games that Matt can buy. Okay, so we're going to start with this $50 gift card. So this is going to go on the right. This is what Matt has. So anything going on over here has to be less than or equal to 50. He can spend 50 and he can spend less than 50, but he can't spend more than 50. Okay, now we have labeled the number of games as X and the number of apps as Y. So let's see what we have here. We know that the games cost $2.50 each. So we're going to take that times the number of games. And then we're also going to include the $1.25 for each app. Okay, we need to put that in slope-intercept form in order to graph it. So I'm going to bring that 2.5 to the other side. Less than or equal to negative 2.5x plus 50. I'll divide everything by 1.25. And I'll just bring that down there. So I end up with y is less than or equal to negative 2x plus 40. Right, so we know here that's going to be a solid line, and we're going to shade below. Okay, so I'm going to start with 40. Now I'm going to go down to units. I made each unit here worth 5. So I can go down 2 units. It's consistent on both the x and the y. So I'm going to go down 2 to the right 1, down 2 to the right 1. I'm going to keep going. Now that's going to be a solid line. And I'm going to shade below. So this is everything that Matt would be able to afford. Any combination, including those that are on the line, that it falls in that shaded region. So it says here, name a possible combination of apps and games that Matt can buy. So if we pick, doesn't really matter, anything in the shaded region. So I could pick something like this, something here, which would mean 5 games and 15 apps. So anything within there on that shaded region or on that solid line is a possible combination that Matt can afford. Okay, we're going to continue on. We're going back to VUX or HOI, which we've talked about in just graphing lines. Now we're going to use it again when graphing inequalities. So just as a reminder, the VUX stands for vertical lines. They have an undefined slope, and their equation of the line begins with x. X is equal to a number. That's going to be a vertical line, right? Something like this. A horizontal line, which runs in the other direction, my HOI, horizontal line, has a 0 slope, and again, the equation of the line is y is equal to a number. Okay, let's get started. So in number 1, we have an x, which is a VUX, so we know we're going to have a vertical line. And I know that 2 is where it's going to go. It's going to go through there. So we're going to draw a line there. This is going to be solid. So I'm going to draw my solid line. Now the greater than means it's going to be shaded above. So we need numbers that are above 2. All of the numbers that are above 2 appear on the right-hand side of the line. So we're going to include that shading there. Okay, we're going to look at the next one. This one again is a HOI because it has a y. And we're going to go through negative 4. But this time we know, because we don't have a line underneath here, we know it's going to be a dashed line. So I'm going to dash it here. And it's talking about numbers that are less than, right? Less than or equal to there is going to be less than. Numbers that are lower than 4 appear here below the line. Okay, now in number 3, we don't have our variable by itself. I realize that there's no y there, but I have to get my x by itself in order to graph. So I have greater than or equal to 4. I divide everything by negative 4. Now, remember, when you divide by a negative number, we need to change the direction of the sign. So I have x is less than or equal to negative 1. So I'm going to have a solid line where x is equal to negative 1. That's a vertical line, right? That's a VUX. And numbers that are less than or equal to negative 1, they appear over here on the left-hand side. Okay. All right, so for our last type of problem today, we are going to take a look at the graph. So it says the graph of y is equal to 3x minus 4 is shown. That's just the graph of the line. But now they're talking about what happens if we make that an inequality. So when we have a greater than, it's going to be a dashed line, and we're going to shade above. Okay, so I'm just going to change that to my dashed line, just so you can see dashed line, and we know we're going to shade above. Okay, so a couple things we can do here. It's saying consider the solutions, rate each point in the appropriate column. So is it a solution or not? So there's two ways we can do this. We can just look at the graph, right? So I have negative 1, 2, 3, 4, 5, 1, 2, 3. That would be here. So that's yes, that's a solution. Now, if I wasn't given the graph, I have this over here. I could also substitute my values in to see if I get a true statement. So I have negative 3 is greater than negative 15 minus 4. So negative 3 is greater than negative 19. That's true, which is why that's a solution. Okay, I'm going to do the same thing with the next one. 0, negative 4. So 0, 1, 2, 3, 4. That actually appears on the line, but that's a dashed line. So that's not a solution. If it was a solid line, it would be okay, but it's dashed, so we're not including points on that dashed line. Again, I could substitute that in and see what I get. So I have negative 4 is greater than negative 4. Now that's false. Negative 4 isn't greater than negative 4, right? It's equal to. So that's why it falls in the not a solution. Okay, so you can pause the video now or take a look to see how the other points, where they fall. I'm just going to take some time and I'm going to substitute it in. So negative 3, 4 is a solution. So is 0, 0. So is 1, 1. Not a solution is 1, negative 7. That falls outside the shaded region. Same thing with 2, 2. Not a solution. And same thing with 4, 2. So again, if you want to pause that, double check that shaded region to see where things fall, you are welcome to do that. Okay, thanks so much for stopping by today. You have a great day.